are for the Unit 5 study guide, the Unit 5 review. Okay, number 1, fill in the table to show a linear function. Okay, so a linear function always has a constant rate of change. Okay, so it has a constant rate of change. Okay, rate of change, it's always multiplying by 3, it's always adding by 5. Doesn't always have to be addition. It can be multiplication, it can be division, it can be subtraction. It just has to be they are doing the same thing every single time. It's constant, okay? So from -1 to 2, that happens to be adding 3. So -1 to 2 plus 3. And then from 2 to 5, it also is adding 3. So that means that every step of the way, it is adding 3. Okay, so if I were to work backwards, what plus 3 is -1? Okay, that's going to be -4. And the way that you can figure that out is you can actually just subtract 3. If you're going backwards, you can work backwards. So from here to here is plus 3, but from down to up, you can just minus 3, so that's -7. Okay, these are always skipping by 1s. Okay, so 0, 1, 2, -2, -1, 0. All right, here it looks like we are going down. So 3 to 2.5 is a decrease. Okay, if I were to do 3 minus 2.5, okay, it looks like it went down by 0.5. So every other should decrease by 0.5. Decrease by 0.5. That's subtracting 0.5. So 2.5, okay, minus 0.5, that's 2. Okay, minus another 0.5, that's 1.5. And just to check, minus 0.5, that is 1. So we had the right pattern. Okay, and then it goes 0, 1, 2, and then going backwards, 0, -1, -2. Number 2, fill in 3 attributes for each function. So we need 3 ways to describe this function. Okay, looking right here, I see a -x. Okay, so that negative is telling me it's decreasing. I know that whenever I see an exponent on x, that means it's nonlinear. And I know when that exponent is 3, it is a cubic function. Cubic function. Okay. Here I see that the x is positive, so it is increasing. I see that the x has an exponent, so it is nonlinear. And the exponent is 2. That means it is a quadratic function. Okay, cross out all of the functions. So we are going to keep the ones that are not functions. So 2x plus 1, that is a function. It'll create a straight line. So that one's out. This is also a straight line. So that one's out. That is a linear function. It passes the vertical line test. Okay. Does this pass the vertical line test? No, it does not, because it crosses the vertical line, which is my pen, twice. So that is not a function, so we're going to not cross it out. This one, we just cannot have repeating x's. Okay, and these are not repeating. That means that this is a function, so crossing it out. And for this to be a function, it would need 1 arrow from each input, and there's 2 here. So it is not a function, so it remains untouched. All right, same thing here. 1 arrow from each input would make it a function, so therefore that is a function, so cross that one out. The input cannot repeat, and those are repeating, so that is not a function, so it stays untouched. This is a function because it does pass the vertical line test, so I cross it out because it's a function. cannot have any repeating inputs. So 1, 2, 3, 4, 5, that is non-repeating. Output does not matter, only input does. So this is a function, cross it out. And this does not pass the vertical line test because it would touch those 3 dots at once. So that is not a function, it remains untouched. Okay, second page, looking here. Domain is all of our x values, and range is all of our y values. Okay, so scanning the graph, it looks like our first x value happens at +1. Our next one is at 2. These are at 2. That's 3, and then our next one is at 4. And right there, I just noticed, look, these 3 dots, if I did a vertical line, they are going to all touch that vertical line at once. So I already know that's not a function. Our y values, starting at the bottom, there's nothing down here. Looks like our lowest y value is at 1. Then there are 2 at 2. There's 1 at 3. And there's 1 at 4. Okay. Same thing, domain is our x values. So let's see, we have a dot at 1. We have a dot at 2. We have a dot at 3. We have a dot at 4. We have a dot at 5. And we have 1 at 6. Now, I believe this will pass the vertical line test because none of the dots are on the same x coordinate. So yes, this is a function. Okay, and my range is my y values, so my lowest one is at -1. There is 1 at 0. There's 1 at +1. There's 1 at 2. There's a dot at 3, and there's 1 all the way up at 6. All right, to create a graph for the following story, y-axis is distance, so distance. X-axis is time. Okay. D = 0 is home, so home is here. Okay. Just trying to get some light on my paper. Okay. All right, so the first one's going to be A. So this is for A and this is for B. Mr. Jones travels to work. Okay, so if he's going to work, that means he's probably starting from home, and immediately turns home, then goes to the park and stays there for the rest of the way. So he goes from home to work. So that was to work. Let's say work is maybe at the very top. So let's actually make that go all the way to the top. Okay. Then goes, immediately returns home. Okay, so he doesn't even stay at work. He just goes straight home. Okay. Then goes to the park. Park is maybe halfway. And then stays there for the rest of the day. Maybe he decided, I don't want to be at work today. So he's there for the rest of the day. Okay. Mr. Jones leaves home and travels to work, stopping at the shop on the way, purchases a few things, then heads to work. So home, and then he stops at the store. So home to store. Obviously, he's in the store for a little bit, so it needs to be flat. Purchased a few things, and then from there he goes to work. Okay? All right, select all non-linear tables. So non-linear means that there is not a constant change. And remember, to find the rate of change, it is change in y over change in x. Okay? So this is called f of x. It's also just known as y. So we can think of that as the y row. From -9 to -6, you need to add 3. Okay, from -6 to -1, you need to add 5. And from -1 to 14, you need to add 15. Okay, from -7 to -7, you don't need to add anything, it's just +0. From -7 to 2, it's +9. And from 2 to 16, it's 14. Okay, so that's how much it's changed. So now I do the change in y over the change in x, and I see if it's the same fraction every time. If it's the same fraction every time, then it is a same rate of change. So 0 over 3 is 0, okay? Okay, 9 over 5 is 1.8. Well, those are not the same rate of changes, so this is a non-linear function. Okay, same process here. From 1 to 4, it's +3. 4 to 6 is +2. 6 to 7 is +1. -7 to 23 is +30. 23 to 63 is +40. 63 to 89, I'm just checking, 26. Okay, so now I need my rate of change, so change in y over change in x, so 30 divided by 3, that's 10. 40 divided by 2, that's 20. That's a different rate of change from here to here, so that would be nonlinear. Okay, this one right here, from 17 to 37 is +20. 37 to 57 is +20. 57 to 72 is +15. 3 to 7 is +4. 7 to 11 is +4. 11 to 14 is +3. Let's check. 20 over 4 is 5, okay? 20 over 4, obviously that's 5, it's the same numbers. Okay, 15 over 3, that's 5. So the same rate of change each time is happening means that is a linear function, so we are not going to circle that one. Okay, -2 to 0, you +2. 0 to 6, +6. 6 to 9, +3. 0 to -4, you are subtracting 4. -4 to 45, you're adding 49. And 45 to 96, let me just check, is 51. You're adding 51. Seems kind of sporadic, but let's just check. So -4 over 2, that's -2, okay? 49 over 6, I don't think that's going to be -2. It is not. Not the same rate of change. It is nonlinear. Okay? -3 to 2, that is +5. 2 to 13 is +11. 13 to 17 is +4. Okay? 21 to 26, -26, that's -5. It's getting more negative. 26 to 59, that's +85. And 59 to 41, that's 18. Okay, so now we'll do -5 over divided by 5, that's -1. 85 over 11, that is not the same rate of change, so that is a nonlinear table. Okay, -7 to 0, that's +7. 0 to 9 is +9. 9 to 12 is +3. -10 to -3 is +7. -3 to +6 is adding 9. And 6 to 9 is adding 3. Okay, let's see. Oh, look at this. 7 over 7, that's 1. 9 over 9, that's 1. 3 over 3, that's 1. That is a linear function. All right, I'm going to go ahead and pause this video. Check out the next video for the next 2 pages.